Welcome to anyone watching, it's Craig at mysimpit.co.uk and welcome to part 15 of the front dash build. In this video we're going to look at two panels. The first will be the nav panel and also the digital clock, and we'll look at the design of these and then we'll look at their implementation into the front dash. Let's buckle up. So we'll start by looking at the nav panel, and the nav panel's really just made up of three main components. The first will be a simple on-off toggle switch, and I'm planning to use at this point one of the actual ones took from a Tornado panel that I'd used previously when I stripped several for the armament panel. And these certainly have a good feel to them and should fulfill that part nicely. The next bit is these square push buttons, which are backlit based on the status of that navigation mode selected. And when I designed the TISL panel, which was really installed as a placeholder, I used the ones that we can see here, and I did like that one. It's straightforward switch, quite cheap, got it online, and I'm now looking to use that in the nav panel. And you can make out on the right hand side here the part number for that, should it be something that you want to look into and maybe order online yourself. And the last part are the homing lights, and for those it will just be a circular equivalent version of that same style push button, but this will be used purely from the point of view of backlighting based on the homing status. And again, on the left hand side there you can see the part number. Now with all of these parts here, they need to be powered by a 12-volt supply, and obviously that couldn't be direct from the Arduino. So for all of these bits here, that's 9 different parts. We've got the 7 square push buttons and then the 2 circular buttons. We're going to use this module, and what this is effectively an Arduino based MOSFET. I think it's IRF 520N. I think you can see that on the middle picture there. And these come in really handy as a way of, when a signal's received from the Arduino, simply to say that the state of a pin goes high, a separate external power supply can be fed through to power that component. And if we take a close look at that now, we can see what is a typical description here for one I've purchased online. I got a heap of these from AliExpress, and I did use them in the landing gear panel for the coil of the actual landing gear lever, the lamps, and the magnetically held toggle, and they did work well for that purpose, so I am planning to use them for this one now. In the landing gear panel in that video, you could actually see that I used one of these, which is a version of it that has 4 outputs in one, whereas for this particular panel, the nav panel, I'm looking to use a smaller one because of the footprint of that and the way it will need to be installed into the front dash. So it'll be the one we see on screen, actually used 9 times over. There'll be 9 of these for each of the 9 push buttons that need to be backlit. So it's probably worth taking a moment at this stage just to have a look at a breadboard view of the wiring. What we can see on screen here is an Arduino Mega, which I'm using for this DCS Bios hub, which is housed within the front dash, and a MOSFET, the one that we were looking at just. So it really is as simple as you've got a signal input, which in this case I've just chosen pin 7. So pin 7 from the Arduino is going into the signal input here. Just zoom in a bit on that. Pin 7 to the signal input pin, and then the 5-volt pin of the Arduino going into the VCC pin, and the ground pin on the Arduino going into the ground pin on the MOSFET module. So that's pretty straightforward. What we then have is a power supply. In this case I'll be using a 12 volt power supply, and that'll be connected in, as we can see here, with the positive going into the VIN input and the negative going into the ground, and then that comes out on this header here to whatever component you might be wiring it to. So it could be an LED, a bulb, a coil, whatever that might be. In this case, for the nav panel, it's going to be the rectangular and circular push buttons that have a bulb inside. So the input of the push button could be connected by DCS Bios. I'll, in this case, use my keyboard encoder. But what we're looking at here is how to toggle the status of the bulb to actually turn that bulb on. So if we now take a look at that in conjunction with the Arduino sketch, we'll just bring that up on screen. So what we can see here is a very simple sketch for use with DCS BIOS, and this is what would be uploaded onto this Arduino Mega here. And this just has one snippet of code from the control reference library that just recognises that on pin 7 we've defined pin 7 here as the pin that an LED will sit on, and then when the status of this ILS backlit button within the simulator is illuminated, pin 7 will go high, and that would illuminate an LED connected to it. Well, in this case, when that pin goes high, there's not an LED here which lights up. The signal pin's triggered. That means the MOSFET allows completion of the circuit for this power supply here to pass through, and in this case power that bulb. And it is as straightforward as that for the use of this and for these components to be powered. What we can see now is the use of these switches back when I did the TISL panel, and at that point, to put the labelling on the front of them, I printed on a piece of paper the labels, which I then cut out and put in place. I now spent some time designing and printing test labels to see which will be the best to use. The TISL panel, when I made that, is just a placeholder currently because it's not functional within the sim, and therefore, other than labelling them, I didn't have to be really too concerned about how the light bleeds through. But on the nav panel, they will be backlit and in use each time I fly, so I spent extra time here to just try and find the best way to make it work. So we can see here the label placed within the cap, and we can now click that back onto the switch, and we can have a look what that looks like. It's worth noting that these type of switches do come in both a 12 volt and a 5 volt version. I'd had a whole batch of these from previous where I happened to get them in 12 volts, but like I say, according on how you hook this up, if you use it yourself, you might want to opt for the other one. So we can see there's a lot of bleed of light around the edges, so we need to have a look at improving that. And the light is even bleeding through the black ink itself. So I'll try printing it in different ways of different quality of print, and we can see some variance in results. One on the left here looking much better in terms of limiting the bleed through of light of the ink itself. So I'll move on to something different and try printing on acetate. So the text and symbols are now transparent, which is much better for the transmission of light. The black ink is also not absorbed into the paper, which also lets the transmission of some light and gives a speckled effect. And that's what we can see here. So what we can see now is one of the initial prints when it was on paper. And we'll just try and move over now and have a look at how that looks on acetate. Definitely an improvement. So for the nav panel, I'll label them all with acetate. A further consideration is mounting this into the front dash. Now, the footprint of this panel is quite small. There's a typical width, but not much height. And each of the MOSFETs needs to be mounted and extended at the rear of that. So it's going to extend some way back. So I spent some time just checking what the maximum depth of this can be. So in this case, this would be the maximum depth. I can just pull back the flight stick and it can fit in. But any further I'd have to actually physically remove the flight stick itself, which isn't very good from a maintenance point of view if I need to get to it later. In some of my testing, it becomes clear that the tornado toggle switch that we're looking at here just takes way too much force to actuate. I think if the mounting plate was thicker than the 3mm acrylic, it perhaps would have been okay, but I did make the decision to swap this for a standard toggle. So having considered the type of components I was going to use, the way in which I would power them, and also label them, it's now time to start wiring them all up, ready for interface. Initially a mess of wiring following the soldering. We can then move on to building up the rear layers one by one. And as we said, in principle it is literally just the use of this MOSFET, which is repeated 9 times over, because there are a total of the 9 illuminated buttons. Further into the rear layers, there needs to be a distribution board. So I 3D print a mounting plate on which I can have the distribution rails. And it starts to get interesting now. We can run some initial tests before we mount it into the front dash. So what I'm doing here is just doing some initial testing on what will be the inputs of the navigation push buttons into the sim. So I've just tapped those directly into the data cabinet at this point. With the inputs tested, we can now move on to hooking up an Arduino and DCS Bios and looking at the outputs, which would toggle in the navigation modes now within the sim and watching them update on the physical panel. So prior to installation into the front dash, we'll just take a moment now to have a close look at this completed navigation panel. I've standardised the wiring approach between my panels, and there's a certain amount of colour coding. So RJ45s, we've got 4 in this one. The 2 orange ones represent keyboard encoder, the 2 blue represent DCS BIOS. There's 2 main types of wires used here. The thicker black and red are to carry power, and the other ones are typical Ethernet cable wires, and they tend to be colour coded in a particular sequence. And I use an Excel sheet to record all of the wiring of my panels, so at any point in the future I can look back and I almost know for each wire exactly where it goes from and to. And part of this is for the point of view of maintenance, but also in the future, one day when this Simpit's finally built, there's every chance I'll go back and take a number of panels and do a series of upgrades. Before we now install this into the front dash, as mentioned at the start of this video, we are going to also look at the incorporation of the A10C digital clock. Looking at the digital clock from the A10C, I'm looking to recreate the part of it that we've highlighted here. So the second hand around the edge is not something that will be part of the panel I'm making now. Perhaps that'll be something as an upgrade for the future. But what I do want it to do is be able to capture the center information, which is the time, and also according on the mode that you've put the clock in, it'll also show and display the timer function. In looking at various OLEDs, the one that I've decided to use for this one is the one we can see on screen now. So it's a 1.3 inch OLED. The resolution for this one's 128 by 64. You tend to find they'll come in a number of different colours. White and blue are the most common, and some have a mixture of blue and yellow. And you get different kinds of interface. For my use of it, I found that I2C is one of the most straightforward ones just to connect and get up and running. And one of the last things to consider is the controller type, because that does affect the Arduino library that you will need to use. And this particular one for the 1.3 inch OLED is the SH1106. So I did have to source online and find the library for that. Prior to reaching this point where I'd chosen which OLED I was going to use, I did start off by looking at a number of the most common types, and the three most common types we can see on screen here. And it might be an idea if you're interested in utilising these within your Simpit to jump onto AliExpress and order a good few of each. And then when they arrive, you can obviously undertake your test to get them up and running. It's always worth noting that they do run on different controller types, and most of my initial testing started off with the middle one, which is a 0.96 inch 128 by 64, and the library is the SSD 1306. When I then moved on to using the smaller version of that same one, which is 128 by 32, the one on the left, I found, other than a slight tweak to the SSD 1306 library to tell it that it's of the different resolution, it worked exactly the same in all other ways. However, the 1.3 inch OLED needed a different library altogether because the controller's different. So it might just be worth bearing that in mind as you start running your tests. I spent some time learning exactly how these OLEDs work, where I could put in place a splash screen like what we can see now, and then that it would receive and display the data through DCS Bios from the sim. I can now focus on getting it to display the information specifically for the clock, and in doing that there's several values you have to state that it displays on there. So just playing around with the layout, the type of font, the size of font, just so it looks right. To get comfortable and familiar with each of those three types of OLED, I did spend a fair bit of time practicing with these, and I started initially with a lot of the example sketches that come with the libraries and then building it up from there. And I think it's important to go through those steps so you have a better understanding of exactly how they work. I design and 3D print a mounting plate which will hold the OLED at the back of the panel. A small part of one side of the plate will be seen from the front of the digital clock, so I'll paint it as we can see here. We're ready now to incorporate the OLED into the back of this panel. Also, the silver coloured screws will be replaced with a black hex head screw. I have found that on some of the other panels that did give a much better look. As the data comes through, it's always worth bearing in mind that for the clock, unlike some of the radio frequencies, there's actually three separately stated values of the hours, the minutes and the seconds. So as the data comes through, as you can see there, one of the values was populated just slightly before the others, but usually within a few moments of starting the data stream, say a couple of seconds, it's all present and correct. For the select and control push buttons, I just use a couple of really cheap ones that I'd had lying around. It's actually quite nice to use them. I'd had them lying around in a box from years ago, and I think they literally cost just a couple of pence, so it's nice to just incorporate those into this design and get some use from them. So we're now on the last leg of completing this panel, and we'll just take a moment to have a look at the rear. And it's quite a simple arrangement for this one. There's just one RJ45 socket, the whole thing's run off DCS Bios, a very small amount of backlighting. It's probably worth mentioning here that it'd be worth you checking for the OLED you get what the suggested input voltage is. I've run these just fine off the 5V pin of the Arduino. Sometimes you see people running them off the 3.3 volt. So with the digital clock now completed, we'll just take a moment to have a close look at that whole panel before we incorporate it into the front dash. So as can be seen, the same approach to the wiring's been undertaken with this one as a nav panel, and you can see that there's quite a lot of commonality between all the panels now. The next step is to update the DCS BIOS hub so it's able to receive and talk to the nav panel and the digital clock. So really it just involves the extra wiring needed and the new updated sketch flashed to the Arduino. So we can see the front dash now before we incorporate them and put them in place. The first one that we'll install will be the nav panel, which will be just at the bottom centre of the front dash, just above the tissel. With that one in place, we can now move on and install the digital clock. And there we go. So let's just take a closer look at them as they now sit within that frame. I think that from an aesthetical point of view, the digital clock's functional. It serves its purpose of displaying that key information. I do think it'd be a nice upgrade for the future to go back and put in the outer second hand. And while the nav panel in particular does extend back some way, it's really not an issue because it all just falls within the frame. And as we just bring the video to an end, we'll just take a final look at them now they're all online and up and running. The digital clock is as you see it. It's clear and well displayed. The nav panel, I don't think the camera's really done that justice in the way it shows that, and we'll actually come around and just try and get a clearer view of it. To the eye, the text and symbols is really quite legible on these, and I think it's definitely a good choice to move from using paper to acetate. I think that has made a big difference, and it's got rid of that sort of mottled, speckled effect of the transmission of light through the ink that's absorbed into the paper. You definitely get a clearer print and application of the ink on the acetate. So that's another 2 panels brought online, another nice addition to the Simpit, nice to fly with these, particularly the nav panel. I mean, that's one that you use every time you fly, so some good progress there. So I hope you enjoyed the video and thanks for watching.